Hello, my dear students. This is our SHS 3 Core Mathematics Revision Program. This program is brought to you by the Center for National Distance Learning and Open Schooling. I am Ben Apeudatson. In this lesson, we are going to look at standard deviation and variance of a data. And by the end of the lesson, you should be able to calculate 1. The standard deviation, and 2. The variance of a data. Now you should be able to do this for an ungrouped data and for a group data. I have in the class my hardworking students who are in 3rd year from St. Louis College. Please tell us your name, beginning from my extreme left.
I'm David Kwasi, a final year student.
David, thank you. Next.
Nana Amasafa, final year student.
And
Glennis Yaboa, a final year student.
And
Vanessa Afo, a final year student.
Thank you, my dear students. You are welcome. Thank you. I hope today's lesson is going to be of good help in getting you closer to your A1 in core mathematics. And to you, my dear student watching, you are also welcome. Stay tuned in and enjoy the lesson. In today's lesson, we are going to look at how to calculate the variance and standard deviation of an ungrouped data and of a group data. In our statistics lesson in year 2, we learned about the variance and the standard deviation of a given data. We learned that the variance of a given data describes how the data values are separated from the mean. It is determined by the formula sigma squared equals summation of x minus x bar all squared divided by n. N is the size of the data. That's the number of values that we have in the data. Now for a group data where we have frequencies, the variance is the summation of the frequencies multiplied by x minus the mean all squared divided by n, where n is the size of the data. We can also use the formula summation fx squared divided by summation f minus into brackets summation fx divided by summation f all squared. That is the variance. Now let's look at the standard deviation. The standard deviation of a data describes the average variations of the data values from the mean. It shows how spread out the rest of the values are from the mean. The standard deviation is the square root of the variance. Because we have taken the square root of a value, it means it can be either positive or negative. But normally, in writing, we only use the positive value. The standard deviation is determined by the formula plus or minus square root of summation into brackets x minus x bar all squared divided by n. Or we can use summation f into brackets x minus x bar squared divided by n. Again, we can apply the formula square root of summation fx squared divided by summation f minus into brackets summation fx divided by summation f brackets closed squared. These are the formulas that we are going to play around with. Once you have your data, you can calculate the variance and the standard deviation, as we have already done in year 2. I want us to use these formulas in a few examples. Our first example is the scores from an English test of 10 students are 30, 50, 70, 76, 26, 60, 42, 38, 92, and 49. Calculate 1. The variance. 2. The standard deviation. I want to invite Vanessa, or you all try it, and when you are ready, Vanessa will take us through the solution. You have the data 30, 50, 70, 76, 26, 60, 42, 38, 92, and 49. We have to calculate the variance and the standard deviation. Vanessa, are you ready? What do we do first if you have to calculate the variance?
First, we sum the given data, which is 30 plus 50 plus 70 plus 76 plus 26 plus 60 plus 42 plus 38 plus 92 plus 49, all over the number given, that's 10, which will give us the total number of the total of the top, which is sigma x. It will give us 533 all over 10, which is the total number being given, and we'll get 53.3.
All right, so it means in the formula we have the mean of the data. Therefore, you have to calculate the mean first before you can use the mean to get a variance. Vanessa, thank you very much for giving us the mean of the data, which is 53.3. Now, David, we have the mean. What do we do?
Variance equals summation of x minus x bar all squared over n.
Okay.
We have 30 minus 53.3 all squared plus 50 minus 53.3 all squared. Repeat the process for all. Then simplifying, we have 4016.10 over 10, which when simplified further equals 401.61.
Thank you very much. So that is the variance of the data. We subtract the mean from each of the data values, we square the results, and we sum up. Thank you very much, David. Glennis, how do you get a standard deviation?
The standard deviation is the square root of the variance. The standard deviation is equal to sigma f into bracket x minus x bar squared all over n. Square root of variance equal to 401.6 squared. The answer is equal to 20.04.
That's square root of 401.61. Okay. And that'll give you
20.04.
Okay.
That's the answer for standard deviation.
All right. So we take the square root of the variance and we get 20.04. And that is the standard deviation. Thank you very much. Let's take our second question. The scores from a mathematics test of 10 students are 80, 48, 60, 40, 32, 54, 62, 31, 86, and 55. Calculate 1. The variance. 2. The standard deviation. You all try it. You have the data 80, 48, 60, 40, 32, 54, 62, 31, 86, and 55. You want to find the variance and the standard deviation. Per the formula, the first thing to do is to calculate the mean. I hope you have all calculated the mean. Nanama, how do we get the mean of this data?
Using the formula x bar, which is equal to sigma x over n. And the sigma x is 80 plus 48 plus 60 plus 40 plus 32 plus 54 plus 62 plus 31 plus 86 plus 55 divided by 10. And when we simplify it, I had 548 divided by 10. Further simplification, I had 54.8.
I think that is correct. Vanessa, what did you get?
Same thing.
Same value. So the mean of our data is the sum of the data values divided by the number of data values that we have. And from the calculations, we have 548 divided by 10. We now have our mean. We use this mean to calculate the variance. Vanessa, how do we get a variance?
For the variance, we use the formula sigma into bracket x minus x bar, bracket close, raised to the power 2 all over n.
Okay.
That is x equals the number given to us, like each data, the data given, minus the mean,
Okay.
all squared over the number of the data,
Okay.
which is 10.
All right.
So we'll have for the first one, which is 80 minus 54.8 square, we'll have 635.04
Okay.
plus the next one, which is 46.24 plus 27.04. So we'll continue for each, all over 10.
Okay.
Then for the summation of the first one, we'll get 3039.6 all over 10, which would give us 303.96.
Okay.
So our total of all, the correct answer would be 303.96.
So it means the variance of this data is determined by subtracting the mean value, which is 54.8, from each of the data values, and then we square the results. The squares are then added, and we had a total of 39.6. And when we divide by 10, like Vanessa said, we have 303.96. Thank you very much. We have the variance. David, what will be the standard deviation?
The standard deviation is equal to the square root of sigma f into bracket x minus x bar all squared over n, which is equal to the variation.
Okay.
Simplifying, we have the square root of 303.91. Simplifying further, we have 17.43.
Okay. So with our variance of 303.96, we take the square root of that, and we have 17.43. Thank you very much. Now, I want us to do a little interpretation. You know, our first data was on the scores from an English test. Our second data is the scores from our mathematics test of the same 10 students. For the English, we had a mean of 53.3. a variance of 401.61, a standard deviation of 20.04. For mathematics, we had a mean of 54.8, a variance of 303.96, and a standard deviation of 17.43. Specifically, what does English standard deviation of 20.04 and mathematics standard deviation of 17.43 means? You have two standard deviations. How do you explain that with respect to the data, and specifically with respect to the mean of the data? Yeah, Vanessa, can you help us with an explanation on the standard deviation of English being 20.04 and mathematics being 17.43? What does it mean?
The standard deviation. English has a standard deviation of 20.04.
Okay.
And math has a standard deviation of 17.43. Therefore, English scores are more spread far away around the mean, whilst mathematics scores are closer to the mean.
Okay. So what it means is that with a higher standard deviation, the data values are more spread out than the one with the lower standard deviation. Thank you very much, Glennis. Now we'll take our next question. With this interpretation, we take more questions. We want to calculate the standard deviation and variance of the data. Now this data is in a table form. We have the max and the frequency. We have max 1, the frequency of 6, 2, frequency of 11, 3, frequency of 12, 4, frequency of 15, 5, frequency of 10, 6, frequency of 21, 7, frequency of 18, 8, frequency of 15, 9, frequency of 12, 10, frequency of 10. Now the question is to calculate the standard deviation and the variance. I want you to go through the solution. Everybody should try. Here you need to form a table of values. You use the appropriate formula and you calculate your standard deviation. So let's all go through the table. All right. Let me invite Nanama to take us through the headings of the table. What will be the headings of the frequency distribution table that we are supposed to draw? Yeah, Nanama, what are the headings first?
First, we have the X column,
Okay,
the F column,
okay,
the X square column,
okay,
the FX column, and the FX squared column.
okay. So for us to be able to calculate the standard deviation, our columns are going to be X, F, X squared, Fx, and Fx squared. Nanama, what are the entries in the X squared column?
In getting the X squared value, we square the X. So for example, 1 squared gives us 1.
Okay,
2 squared gives us 4.
okay,
3 squared gives us 9. 4 squared gives us 16.
okay,
5 squared gives us 25. 6 squared gives us 36. 7 squared gives us 49. 8 squared gives us 64. 9 squared gives us 81. And 10 squared gives us 100.
all right. What about Fx? How do you get Fx?
In getting Fx, we multiply f by x.
Okay,
That is 1 times 6, giving us 6. 2 times 11, giving us 22. 3 times 12, giving us 36.
Okay.
4 times 15, giving us 60. 5 times 10, giving us 50. 6 times 21, giving us 126. 7 times 18, giving us 126. 8 times 15, giving us 120. 9 times 12, giving us 108. And 10 times 10, 10 times 100. No, 10 times 10, giving us 100.
Thank you very much. So it means with our fx column, we multiply the values of x by the values of f, corresponding values. Now we need fx squared. That is f multiplied by x squared. Vanessa, can you help us?
For fx squared
Yes.
is the x squared multiplied by the f.
By f, okay.
Yes. So like Nanama said, we multiply the f, which is the frequency, by the fx. That's the x, which is squared. And for the first one, that is 6 multiplied by 1,
Okay.
which is 6. So we go to the next one, that is 11 by 4, that's 44.
Okay.
And then the next one is 108. The next 240,
Okay.
250, 756.
Where are you getting the 756?
That's from the 21 multiplied by the 36.
Okay. Okay. So 21 by 36
Yes,
is 756.
Yes.
Okay.
And then the 18 by 49 is 882.
Okay.
15 times 64 is 960. And 12 by 81 is 972. And 100 by 10 will give us 1,000.
Okay. So we find our fx squared. That's the product of f and the x squared values. Then we sum. David, what will be the sums of the f's, the fx, and the fx squared?
Okay. When you sum the values of the f, you get 130.
Okay. Are you all getting 130?
Yes.
All right.
And for fx, you get 754.
Okay.
And for fx squared, you get 5218.
5218. So we have our totals for the f's, that is f, fx, and fx squared. David, how do you get a standard deviation?
The standard deviation is equal to sigma fx squared over sigma f minus sigma fx over sigma f all squared.
Okay, so it means
Find the
because
square root of that.
we found our f, our fx, and our fx squared, we pick this formula. That will be the appropriate formula, right?
Yes.
Do you agree? Okay. Yeah, continue, David.
The standard deviation is given by the root, the square root of sigma fx squared over sigma f minus sigma fx over sigma f all squared. Substituting, we have the square root of 5218 over 130 minus 754 minus over 130 all squared, which gives us square root of 40.14 minus 5.8 squared. Simplifying, we have square root of 40.14 minus 33.64, which gives us the square root of 6.50, which is equal to 2.55.
Thank you very much, David. So the standard deviation of our data is 2.55, where we use the formula square root of summation fx squared over summation f minus summation fx over summation f all squared. Thank you very much. How do we get the variance? We are also to calculate the variance. We have the standard deviation. Glennis.
The variance is equal to standard deviation squared. The answer for standard deviation is 2.55. So in order to get the variance, we have to square 2.55 to get the variance. So 2.55 squared is equal to 6.50. Therefore, the variance is 6.50.
Thank you very much, Glenys. Students, I hope you have observed that in this particular question, we were asked to calculate the standard deviation. So we used the appropriate formula, and we had 2.55. In finding the variance, you square the standard deviation to get the variance, and that is 6.50. Thank you very much, my ladies and my gentlemen. Let's take our last example. The data we have shows the ages of a group of people. We are to calculate the variance and the standard deviation of the ages. This data is a group data. We have age and frequency. Our ages are 0 to 4 with frequency of 8, 5 to 9 with a frequency of 12, 10 to 14 with a frequency of 10, 15 to 19 with a frequency of 15, and 20 to 24 with a frequency of 9. This is a group data, and we are to calculate the variance and the standard deviation. I'm sure you have all started preparing your frequency distribution tables, where you need your x, your fx, and your fx squared. Be mindful this time you don't have your x, you have the intervals. So you need to compute your x first. That's a class mark. I'm sure you are done with the table. Let me invite Vanessa, if you are ready. How do we find the class mark of this data?
For the class mark x, which is x, we would add the class interval.
Okay.
So we'll add 0 plus 4 and we'll divide it by 2.
Okay.
So we'll get 0 plus 4 giving us 4 divided by 2, which would give us 2.
Okay.
So we'll do that for all the intervals.
What will be the second one?
The second one is 5 plus 9, which would give us 14.
Okay.
Divided by 2, which will give us 7.
Okay.
The third one, that is 10 plus 14, would give us 24. Divided by 2 would give us 12.
Okay.
Then the next one, which is 15 plus 19, would give us 34. Divided by 2 would give us 17. Then the last one, which is 20 plus 24, will give us 44. Divided by 2 will give us 22.
That is excellent. Nanama, thank you very much. I'm sure my students up there, when you are given a grouped data and you are to calculate the variance or the standard deviation, computing your class mark will not be a challenge. Vanessa, thank you very much. David, we have our class mark. How do you find the fx? What do you have?
To find the fx, you multiply the f values by the x values.
Okay.
So 8 times 2, which will give you 16.
Okay.
12 times 7, which will give you 84.
All right.
10 times 12, which will give you 120.
Okay.
15 times 17, which will give you 255. 9 times 22, which will give you 198.
Very good. So that is how we calculate our fx. You multiply the f values by the corresponding x values. Glenys, have you done fx squared? What are your results?
For the fx squared, you need to multiply the x squared by the f values. And
But we don't have x squared on the table.
yes.
Okay.
So in order to get that, we have to square the x values.
Okay.
So if you square the x value, if you square 2, you're going to get 4. If you square 7, you're getting 49.
Okay.
If you square 12, you're getting 144.
Okay.
If you square 17, you're getting 289.
Okay.
If you square 22, you're getting 484.
Okay, so we can include the x squared on our table.
Yes, please.
Thank you very much. Then what follows?
So in order to get the fx squared,
Okay.
you need to multiply the x squared values I just gave to the f values.
Okay.
So if you multiply the 4 by the 8, you're going to get 32.
Okay.
So you do that to the other values that are following. So 49 by 12, you're going to get 588.
Okay.
The next value, you're getting 1,440. The next value, you're getting 4,335.
Okay.
The next value, you're getting 4,356.
Okay, that is correct. That is correct. So you multiply your f by your x squared values, or you can simply multiply the f by, for instance, 9 multiplied by 22 squared on the calculator, and you get your fx squared. Thank you very much, Vanessa. Glenis, right? Thank you. Let me invite Nanama in. Nanama, what are the totals? Have you calculated them?
Totals
For f, for fx, and fx squared.
for the f, when I added, I had 54.
David, did you get the same thing?
Yes, sir.
Okay.
For the fx, when I added, I had 673.
Vanessa, what did you get?
600.
673. Okay.
And for the fs squared, when I added, I had 10,751.
Glenis, is it confirmed?
Yes, please.
Sure.
Yes, please.
So our totals for f54, fx 673, and fx squared 10,751. I hope you also have the same values. Now let's continue. Variance. How do you get a variance?
In getting the variance, the formula is sigma fx squared over sigma f minus, into brackets, sigma fx over sigma f all squared.
Okay.
So we substitute the values.
Okay.
Sigma fs squared, we had 10,751
Okay.
over 54 minus, into brackets, 673 over 54 all squared. So when I simplified, I had 43.77.
43 point.
77. Sorry.
43 point.
77.
43.77. Thank you very much, Nanama. The last bit is the standard deviation of this data. Vanessa, what will be the standard deviation? How do we calculate the standard deviation? From the stage we are now, what do we do?
We know that to get the variance, you have to square the standard deviation.
Okay.
So in order to get a standard deviation, we have to find the square root of the
Variance.
Sorry.
Okay.
So we have the variance square root. So the square root of the variance, which is 43.77 square root, which would give us 6.62.
All right. So it means the standard deviation for this data is 6.62, and that comes from the square roots of the variance. Thank you very much, ladies and gentlemen.
Thank you too.
This is what time will allow us. In this lesson, we have tried to calculate the variance and the standard deviation of a data. We looked at the variance for an ungrouped data, that is summation of x minus x bar all squared divided by n, or we can use the formula summation f x minus x bar all squared divided by n, or summation fs squared divided by summation f minus summation fx divided by summation f all squared. You use the appropriate formula depending on the type of data and the kind of information that you have. We also said that the standard deviation is the square root of the variance. So you calculate your variance and then you find the square root, and that gives you the standard deviation. On the other hand, if you have calculated your standard deviation and you want to find the variance, then you square the standard deviation to get your variance. My dear students, we appreciate your efforts and time spent with us. We thank you very much for coming, and it's our hope that when we invite you again, you'll be here to share with us a few thoughts on how to answer some questions, how to prepare for examinations, and what you have done for us. I know your A1 is assured. Do you believe in that?
Yes.
Thank you. Thank you for coming.
Thank you too for having us.
This brings us to the end of our revision lesson for today. I am sure this has been helpful for you. Please make a date with us for the next revision lesson, which is on rules of logarithms and their application. Till then, it's goodbye.